Let's move on to loops. We will first discuss the for loop. The for loop is useful for iterating over a range of numbers. If we want to run a piece of code each time with a different number in some range, the for loop is the ideal choice for this kind of task. Let's look at an example. For example, we want to sum all the numbers from 0 to 99 inclusive. The idea of using a for loop is going to look like this in pseudocode. I remind you that this is only some kind of an idea. This is not a real code. This is the high level idea of what a for loop looks like. We can say that we have this interesting statement for ECX from 0 to 99 do, which actually means take ECX and each time put a different number inside of it. Begin with 0, then move to 1, then 2, and so on until 99. And each time that you do this, you should run the clause that resides inside the for, which means that this piece of code, EAX plus ECX is stored inside EAX, is going to be invoked for every different value that ECX gets. So this part of code is going to run actually 100 times. This is pretty powerful. It means that we can choose some piece of code and make it run as many times as we want. Computers can actually do it. I think it is very exciting. Imagine that you had to do it. But no, you don't have to do it. The computer can do it for you. How could we implement this kind of idea, this kind of for loop, using assembly? We have a solution here on the right. Again, I try to space the pseudocode so that every line in the pseudocode corresponds to the relevant line in the assembly code. Especially the colored line, which is the actual inner clause of the for loop. The rest of the lines are just the for loop. Even in the assembly code, all those white lines are just the meta. They are not the real thing. The real work being done is the colored line, this red line. Let's speak about the assembly code that we see here. First, we initialize ECX to 0, which is reasonable because we want ECX to have a different value every time and we want to begin from 0. Then we do this line, which is the actual work inside the loop, which is mostly about summing the numbers. EAX is going to contain the current sum of all the numbers that we've summed so far, and ECX is going to have the job of being the current number. ECX is some kind of index. It always increases. After doing the loop iteration, which is just this line, we are going to prepare ourselves to the next iteration of the loop. This is done by increasing ECX, and then we check if the loop should end. Maybe we have reached to the end of the loop. We have to check it. When we reach the end of the loop, we would like to exit it. In order to check it, we just compare ECX with 100, and as long as it is not 0, we just continue the loop. You might be asking yourself, why 100? We have 99 here, so what's with the 100? I remind you that we wanted to sum all the numbers from 0 to 99 inclusive. That means that we want to stop only when we get to 100, and we don't include the 100 in the sum. Therefore, we compare to 100 and not to 99. Let us summarize the parts of the for loop in assembly language. First, there is the initialization. the initialization is going to be outside the loop. The part of the loop is from here, from the for loop label, until the jump node 0. This is the initialization. It should be invoked only once. We don't want to zero the index of the loop every time, only in the beginning. Then there is the label of the loop, and right after it, we expect to have the actual work that is done in every iteration of the loop. And this work could depend, for example, on the index. Here we can see that the addition depends on the index. It depends on the value of ECX, which changes in every iteration. Finally, the last part is going to be about two things. About increasing the index, and then about checking if the loop has ended. If it has not ended yet, we move on to the next iteration. If it did, we just go out. We continue to execute the rest of the code in our program. Let's take a look at another kind of loop. This time it is going to be the while loop. As its name says, this kind of loop is useful to keep going as long as some condition is fulfilled. Just something to think about, a for loop is a specific type of a while loop, where the condition to be fulfilled is that the index becomes big enough. In the future, you will have even a better understanding of this statement. Let's look at another example. It is pretty similar to the previous one, but there is some difference. We are going to sum the numbers beginning from 0, then 1, then 2, then 3, and so on, until we get to the sum of at least 1000. It doesn't mean that we are going to sum the numbers from 0, 1 until 1000. We actually sum numbers until the total sum is of size at least 1000. Let's look at the pseudocode. In the pseudocode, we first initialize ECX and EAX to be of value 0. EAX is going to have the job of being the total sum, just like in the previous example, and ECX is going to be the index. It is going to increase in every iteration. Let's take the actual work done inside. It is marked by purple, and those commands inside the loop are going to be invoked in every iteration of the loop. The pseudocode actually means that inside the while loop, this part is the actual work to be done, and it is going to be done again and again until EAX is greater or equal than 1000. Or in other formulation, the inner code inside the while loop is going to be executed as long as EAX is smaller than 1000. Let's take a look at what happens inside. First, there is the summation. We add the number ECX into EAX. And then there is the increasing of the index. We actually increase the index ourselves here. I remind you that in the for loop, the index was actually increased automatically, pseudocode speaking. But inside the while loop doesn't actually care about ECX. It mostly cares about the total sum. The while loop only has the responsibility of checking if the total sum is smaller than 1000. It doesn't have the responsibility of increasing the index. This is one thing that is different between for loop and while loop. So it is our responsibility to increase ECX here. Let's take a look at what happens in the assembly code, the equivalent assembly code. We can see that those two commands, zeroing ECX and EAX, are pretty much equivalent to those two move instructions. Then we have the while loop, which begins with this label. As expected, we first check the condition. This part of code is going to check the condition and see if it is fulfilled. I remind you that the condition is about EAX smaller than 1000. So we check if EAX is smaller than 1000 in base 10. That is why we have this D here. And maybe not very surprisingly, we check the opposite condition. We are going to check if EAX is greater or equal than 1000. If the opposite condition is fulfilled, then we immediately exit the loop. We jump to end while. But if the opposite condition is not fulfilled, then we go on to execute the actual iteration, the actual work inside the loop, which is consisted of those two instructions, which correspond to these two commands in the pseudocode. We just have the summation, which is add EAX ECX, and then we increase the index, ECX. Finally, we have this jump instruction, which is always taken. I remind you that the jump instruction is unconditional. It is always taken. There is no decision here. This jump is always going to be taken, and we are stuck inside this loop here. We can only exit it using the condition. The while loop just continues forever, and it only stops if the condition is not fulfilled. Let's summarize the parts of a while loop in assembly code. We expect to have some kind of initialization in the beginning. Then we have the while loop label. Immediately after it, we check the fulfillment of the opposite condition, the inverse condition, and if the inverse condition is correct, we immediately exit the while loop. Then we have the part of code that executes the actual work, the actual iteration inside the loop. And finally, we have an unconditional jump that is always taken. We also have this end while label, which allows us to jump outside the loop using the check of the condition. One thing important about this example is that in the end of this while loop that we have here in the example, we must have that EAX is greater or equal than 1000, which is actually the inverse of the while condition. Breaking from loops. Sometimes you might want to end your loops earlier, maybe earlier than planned, maybe earlier than the while condition, or earlier than the for iteration. We use the break higher level construct to exit the loop immediately. We have the possibility of using this kind of construct, the break higher level construct. Break exits the innermost loop currently running. That means that if there are many loops nested inside each other and we use the break construct, then we are going to exit only the innermost loop currently running. And we can combine this high-level construct both with for and while loops. Let's look at an example. Again, we are going to calculate the sum, 0 plus 1 plus 2 and so on. And we want to find the first moment where the sum is at least 1000. This is pretty similar to the previous example that we had with the while loop. However, this time, we have another condition. We don't want to sum more than 300 numbers. So there are two conditions at the same time. We want to iterate as long as the sum is smaller than 1000 in decimal, and at the same time, we don't want to sum more than 300 numbers. So, you can see that there are two different conditions here. Let's look at an example pseudocode. Take a moment to look at it. We can see that we first initialize EAX to be 0. I remind you that EAX is going to keep the sum at every point, the sum of all the numbers. And now we have a pretty usual for loop. We've already seen this kind of for loop, which is going to iterate from 0 to the number 299, and it is going to sum all the possible ECXs. It puts a different number inside ECX every time, and EAX is going to contain the current sum of all the ECX values. Now we have another thing here. We have this if condition inside the for loop. So this if is nested inside the for loop. The greatest power of the high-level branching constructs is the ability to nest them. When we do something like this, like nesting an if statement inside a loop, if we use high-level constructs of branching, we actually make sure that there are no intersections. There are no intersections between the branches, because the if is pretty much self-contained, and also the for is pretty much self-contained, and they don't intersect each other. We are going to see this in a moment in the assembly code, but this is a pretty important feature of the high-level branching constructs. They can be nested inside each other. Going back to the code, if EAX is greater or equal than 1000, this is just an idea. The symbols that you can see here, they convey the idea that if EAX is greater or equal than 1000, then we are going to break. This break is actually, as an idea in the pseudocode, is going to find the innermost loop, which in this case is the for loop, and it is going to break, which means that it is going to end the loop immediately. Maybe, for example, when we get here, ECX is not yet 299. Maybe it is only 200. And if we get to this point where EAX is greater or equal than 1000, we break immediately. This is what we want to be able to achieve with assembly code. Now let's take a look at how the assembly code looks like. The assembly code that achieves this idea that we can see in the pseudocode. Again, I remind you that I tried to space the pseudocode so that every line in the pseudocode corresponds to an equivalent line in the assembly code. And the colors should be helpful. They should help you match the corresponding lines. So let's begin with the initialization. We can see that initially EAX is set to 0. And we can see also in the assembly code the same. EAX is 0 in the beginning. Then we have the for loop. In the first part we can see here, it is also marked by green because it actually belongs to the for loop. It is the initialization of the index, initialization of ECX. Then we have the for loop label, and now we are actually inside the for loop. These three instructions, the add, compare, and jump above equal, are actually the inner part of the for loop. This is actually the iteration. If we skip those for a moment and go to the end of the for loop, this is a pretty much standard ending for a for loop. We have the index increased, and then we check if the index has become the last possible number. For example, here we are iterating from 0 to 299, Therefore, we compare with 300, which is just 1 above 299. And then finally, there is this jump below, which is going to happen only if ECX is still smaller than 300. So this is a pretty much standard ending for the for loop. There is a bit of a difference with the break idea. The addition of the break idea in the pseudocode is expressed here in this instruction, in the jump above equal and for. The previous two instructions are mostly things that we have already seen. The first one is going to add ECX into EAX, which is actually the summation process. This is how we sum all the numbers. Then we have the if condition. We compare EAX with 1000. We have already seen this kind of if statement too. It is just about comparing and jumping. So these two instructions are actually the representation of the if construct in assembly language. So we compare EAX with 1000 and check if EAX is greater or equal than 1000 using this instruction, the jump above equal instruction. And now something special happens. If the condition is fulfilled, if EAX actually greater or equal than 1000, we exit the loop. We exit it by jumping to this special label, end4, which is going to end the loop. I want to take a moment to look at the branches here and make sure that they are non-intersecting. We have this if construct, and the jump above equal end4 actually jumps to this label end4. One might say that there is a bit of intersection between this jump above equal to end4, and this jump below for loop, which jumps here. This is maybe the only intersection that you are going to see in the higher level construct of branching. We are sometimes going to use it because the break statement or the break idea could be very useful. This is not much of an intersection because there is only one line of a difference. The jump here to the end 4 and the jump here to the for loop. We could actually imagine that these two are on the same line. This is how you are going to implement an idea of breaking from a loop. I think it is pretty cool to see this actually in assembly. Mostly if you had some kind of experience with higher level programming languages, I think that this might be pretty enlightening to see this kind of code in assembly language. Some words about termination of the loop. In the end of this loop, either EAX is larger than 1000, or we have iterated over all the numbers from 0 to 299. There is no sure way to know this. You are going to have to check it yourself when you exit the loop. So for example, maybe after this loop, you are going to have some kind of comparison. Maybe you would like to compare EAX with 1000 just to make sure that the total summation is bigger than 1000. Because in the end of this loop, there are actually two possibilities. There are two possibilities for termination of the loop. Either EAX is larger than 1000, or we have iterated over all the numbers from 0 to 299.